Hello everyone. In previous class we discussed about addition of nucleophile, that is nucleophilic addition reactions. In that we studied about addition of hydrogen cyanide, addition of sodium hydrogen sulfide, and last one is addition of Grignard reagent. And that is third one. Hope you already referred previous lesson for addition of Grignard reagent to carbonyl compounds. Next one is addition of alcohols. Here aldehydes on reaction with monohydric alcohols results in the formation of hemiacetal, that is alkoxy alcohol intermediate. Here I'll take RCHO aldehyde which on reaction with the monohydric alcohol R-OH in presence of dry HCl. This dry HCl is important and which results in the formation of RCH OR dash and OH. Here RH plus and R dash O minus attacks on carbonyl carbon, and as we know carbonyl carbon attacks and bond shifts over here and this becomes O minus and attack of this hydrogen takes place. Hope it is clear for you. R C double bond O H, and here attack of R dash O minus and H plus. It attacks here, bond shifts takes place like this, and it becomes a R C O R dash O minus O minus to O, this O minus H plus attacks, hence results in the formation of a hemiacetal, that is alkoxy alcohol. Alcohol, that is hemiacetal. Okay. This hemiacetal on reaction with another molecule of alcohol R dash OH, which results in the formation of dialkoxy alcohol. Dialkoxy compound. Okay, that is RCH OR dash and OR dash, that is geminal dialkoxy compound. Why geminal? Here alkoxy, two alkoxy groups are attached to same carbon atom, hence it is a gem, and this product is also called acetal. Geminal dialkoxy compound, or it's also called acetal. Now what about ketone? Ketone on reaction with ethylene glycol, that is CH2OH and CH2OH is called ethylene glycol. One more thing, here this reaction is reversible. If we hydrolyze with the dilute HCl, then you will result in the formation of a aldehyde. You can get back the aldehyde, reversible reaction it is. Yeah. Ketone on reaction with the ethylene glycol, which results in the formation of a cyclic product. I'll write both the steps here, dry HCl and in last step, first step dry HCl, and obviously this is there here, and one more is a dilute HCl, mineral acid. What happens? It results in the formation of a cyclic product, that is R as it is, and here C O and CH2 3 4. Okay, this results in the formation of a cyclic product and is called ethylene glycol ketol. It's called ethylene glycol ketol. Okay, and remaining is water. So this is about addition of alcohol to carbonyl compound. First one is aldehyde on reaction with monohydric alcohol in presence of dry HCl results in the formation of hemiacetal, which on reaction with another molecule of alcohol gives a geminal dialkoxy compound called acetal. Next is ketone on reaction with ethylene glycol and in presence of dry HCl and dilute HCl, that is a reversible reaction. Irreversible reaction, you will get back this. And in presence of dry HCl results in the formation of cyclic product and is called ethylene glycol ketol, acetal and ketols, and water. Okay, let us move to the next reaction, that is next nucleophilic addition reaction, that is addition of ammonia and its derivatives, very important one. Okay, I think it is fifth one. Addition of ammonia and its derivatives. Okay, so ammonia, we know the formula NH3 and its derivatives. That is, if you replace one hydrogen atom by any other group like alkyl, aryl or NH2 groups, then it results in the formation of its derivatives. Here ammonia is there. I will replace one hydrogen by Z. Z is a substituent. I will tell about this. NH3 addition of ammonia or its derivatives to carbonyl compound, what we will get. Okay, first this carbonyl compound on reaction with the ammonia or its derivatives then results in the formation of a intermediate, and which on dehydration results in the formation of a product. Let us see how this reaction takes place. That is, first is carbonyl compound on reaction with ammonia NH3 or its derivative, or I will write NH2Z derivative. If Z is H, then is ammonia. Am I clear? Now, carbonyl compound on reaction with the what? It's a derivatives which results in the formation of a intermediate, as I said. Here, first step, nucleophile must be there. Nucleophile is H plus and NHZ. This is nucleophile. Hence, which results in the formation of C double bond O. Here NHZ come and attack over this carbon atom, and hence this bond shifts over here. Okay. Next is results in the formation. I will write NHZ is nucleophile here. N lone pair is there or minus. Hence, it becomes, here it is this bond shifts, hence it becomes O minus. Hope it is clear for you. And it is NHZ. This O minus abstract proton, here NH2Z is there, in that NHZ go and attack over carbonyl carbon and remaining is H plus, and here O minus reacts with the H plus becomes OH. Here this is the intermediate. This tetrahedral intermediate, right, addition of nucleophile, in addition of nucleophile attacks, then tetrahedral intermediate formation takes place. We already studied the mechanism. Readily loses water. Okay, this tetrahedral intermediate readily loses water, OH and one hydrogen from here. Loses water and this bond shifts over here and elimination of water takes place, and hence we get, I'll write carbon here, this one carbon, and here it becomes, this bond shifts, this hydrogen eliminates and here becomes a C double bond, here it shifts and OH goes as water and remaining is C double bond N and Z plus water. Okay, this is very, very important. If you know this formula, you can write any product. Okay, first one is carbonyl compound on reaction with ammonia or its derivative results in the formation of tetrahedral intermediate which on dehydration, which readily loses water and results in the formation of a product. Right? Let us take few examples. First, we'll start with the ammonia. Okay? Just remember the starting material and product. Starting material is ammonia or its derivative NH2Z starting material. Right? Starting material is NH2Z and product is C double bond NZ. Just remember this much. Okay? And Z may be alkyl, aryl, OH, NH2, any groups. Just make 4 columns. In first column Z, in starting material Z is there, right? That one. And second column, name of the reagent. And third is carbonyl derivative. And fourth is product name. Product name. Okay. First one is, if Z is hydrogen, see, derivative is NH2Z. If Z is hydrogen, then it becomes NH3. Am I clear? Ammonia. If Z is hydrogen, name of the reagent is ammonia. Hope it is clear for you. And carbonyl derivative is, as I said, you have to remember this, or mechanism, that is C double bond N and Z is hydrogen, right? Z is hydrogen, that's all. And this kind of products are called imines. Important. Okay, imine. Imine is having general formula C double bond NH. Okay, imine. Next is, if Z is R. If Z is R, then see here, we know NH2Z Z. If Z is R, NH2 R. R NH2 like this. If here R NH2, right, is called amine. Amine functional group it is. If there is R or R dash, any substituent, right, amine. If Z is R, then is called amine. Now carbonyl derivative is C double bond N R, and here 2 bonds. And product name is substituted imine, or also called Schiff's base. Okay, important. Also called Schiff's base or substituted imine. Next one is OH. Next one is OH, and reagent name is hydroxylamine. Hydroxylamine. If you want, you can write how NH2OH, hydroxylamine. Here it is NH2R or RNH2 amine. Hydroxylamine. Hydroxyl group attached. And carbonyl derivative is C double bond N OH, Z is OH, and name of the product is oxime. Be careful, important topic it is. Oxime. Next is NH2. Next is NH2, Z is NH2, then reagent name is hydrazine. It's a hydrazine. And carbonyl derivative is C double bond N. Instead of OH, here it is NH2. And product name is hydrazone. Hydrazone, or you can write here NH2 and NH2. Z is NH2. It's a hydrazine. Here hydroxylamine. So as you know about this amines, ammonia, right? It's called a hydrazone. Next is if we replace one hydrogen of hydrazine here, NH2, if we replace one hydrogen by benzene ring, like this, it results in the formation of this compound. Clear? Okay. This is called phenylhydrazine. Called phenylhydrazine. Okay. And how can we write? NH2 and Z. Z is NH and benzene ring. Right? Phenylhydrazine. And here it is C double bond N single bond. Instead of NH2, Z, here NH2, Z is NH and benzene ring. It's called a phenyl ring. Right? Okay. And is called phenylhydrazone. Phenylhydrazone. Okay. See here, hydrazine, phenylhydrazine, hydrazone, phenylhydrazone. Next is Here, this is functional group attached. To the second position, nitro group is there, and in fourth position also, nitro group is present. Hence, name of this compound is 2,4, first, second, third, fourth. 1, 2, 2,4 dinitrophenylhydrazine. If these two groups are not there means then is phenylhydrazine, right? Because of the presence of these two nitro groups, this compound is 2,4 dinitrophenylhydrazine. Okay, 2,4 dinitrophenylhydrazine, important one, and this experiment is there in your practicals also. Experiment is not there, but for Viva this is there. 2,4 DNP test for aldehydes and ketones. Then what we'll get here, NH2 and NH, and here second position nitro and fourth position nitro, and product is double bond N, NH, okay, C double bond N, NH, and name of this product is 2,4 dinitrophenylhydrazone. Okay, 2,4 dinitrophenylhydrazone. It is used in the detection of aldehydes and ketones. Last one is if Z is NH C double bond O NH2, NH C double bond O NH2, here bond is there. It is called semi-carbazide. Okay, semi-carbazide, and carbonyl derivative is C double bond N, Z is NH C double bond O NH2, and product name is semi-carbazone. So, okay, this is about addition of ammonia and its derivatives to carbonyl compounds. Okay, first we studied about ammonia, then amine, after that hydroxylamine, hydrazine, phenylhydrazine, 2,4 DNP test or 2,4 dinitrophenylhydrazine, and semi-carbazide. These are very, very important for exam point of view. Next is reduction. First, what we have studied, nucleophilic addition reaction, right? In nucleophilic addition reaction, we studied addition of HCl, sodium, hydrogen sulfide, and next is addition of Grignard reagent, after that alcohols, and last one is ammonia and its derivatives, and second reaction is reduction reaction of carbonyl compounds. Okay, this reduction reaction we already studied in previous lesson, right? What is that? Aldehydes or ketones on reduction with catalyst like palladium, or in presence of sodium borohydrate or lithium aluminum hydride, results in the formation of primary or secondary alcohols, right? And aldehydes gives primary alcohol and ketone gives a secondary alcohol. I am not going to explain this, but that must be there in your notes. Okay, that is aldehydes on reaction with the hydrogen in presence of palladium catalyst results in the formation of primary alcohol, right, RCH2OH. And if we take ketone as example, which on reaction with the hydrogen and catalyst or in presence of sodium borohydride or lithium aluminum hydride, then results in the formation of a secondary alcohol, right? Aldehyde always results in the formation of primary alcohol and ketones always results in the formation of a secondary alcohol. Hope you remember these reactions. This is the first reaction in reduction reaction, that is a reduction to alcohols. Okay. In that second reaction is a reduction to hydrocarbon. Reduction to hydrocarbon. This reduction to hydrocarbon is very, very important. In reduction to hydrocarbon, we will study two named reaction. One is Clemmensen reduction and one more is Wolff-Kishner reduction. Okay. Clemmensen's and Wolff-Kishner reduction. Both reactions are very, very important and simple reactions we will study in the next class. Thank you.